Now that we've defined the inner product, we're able to talk about the product of two matrices. So if A, which has elements given by A sub ij, is an M by N matrix, and B is an N by K matrix, then their product, AB, is the M by K matrix given by C, where the element C sub ij is the inner product of the ith row of A and the jth column of B, and we write this product C equals A times B. Now, this is probably looking very confusing, so let's take a look at an example. Let's let A be the 2 by 2 matrix, 1, 3, negative 1, 0, and we'll let B be the 2 by 3 matrix, negative 1, 5, 2, 0, 4, 7. So A is a 2 by 2 matrix and B is a 2 by 3 matrix. We know that we can multiply these because the second dimension of A is equal to the first dimension of B. And furthermore, the result is going to be a 2 by 3 matrix. And so what we're going to do is we're going to have A, B as a product, and we know it'll be a 2 by 3 matrix. And this is how we figure out the elements. For the very first element, it's in the first row and the first column. So what we end up doing to get this result is we take the inner product of the first row of A and the first column of B. So we need to take 1 times negative 1, which is negative 1, and then 3 times 0, which is 0, and add them together. And negative 1 plus 0 is negative 1, so that is the element that goes there. Let's take a look at the bottom right one element. This is the second row and the third column. So to figure out what goes here, we need to take the inner product of the second row of A with the third column of A. So in this case, we would have negative 1 times 2, which is negative 2, plus 0 times 7, which is 0, and negative 2 plus 0 is negative 2. So for all 6 of these elements, we need to take an inner product. Let's take a look at this next one here. This is in the first row and second column. So we need to take the inner product of the first row of A and the second column of B. So that'll be 1 times 5, which is 5, plus 3 times 4, which is 12, and 5 plus 12 is 17. Then for this element, it's in the first row and the third column, so we need to take the inner product of the first row of A and the third column of B. So 1 times 2 is 2, 3 times 7 is 21, and 2 plus 21 is 23. For the next element, we're in the second row and the first column, so we need to take the inner product of the second row of A and the first column of B. Negative 1 times negative 1 is positive 1, 0 times 0 is 0, and 1 plus 0 is 1. And then for this element, we're in the second row, second column, so we take the inner product of the second row of A with the second column of B. Negative 1 times 5 is negative 5, 0 times 4 is 0, and negative 5 plus 0 is negative 5. So this ends up being our product A times B. It is a decent amount of work, and it's probably fairly confusing the first time you do it, but if you look at several of the example problems that are linked below, you will see that this is not that difficult. It just takes practice understanding what you're doing. because all we're doing is multiplying things and adding them, which are skills that you've had for years at this point. I just want to point out that if we wanted to try to take the product B times A, we cannot actually do that. We cannot calculate B times A because B is a 2 by 3 matrix and A is a 2 by 2 matrix, and the second dimension of B does not match up with the first dimension of A. So that is not going to work. What this means also is that multiplication of matrices is not commutative. BA is not equal to AB. And in the first example linked below, you'll get to do another multiplication problem where you'll see even when the dimensions work so that we can take the products AB and BA, the products are not equal to each other.